Okay, we are going to do 9.2 part A, and then we are going to do part B in the same video. So there are two points. There are two lines actually. For line 1 is going through 2 points, and line 2 is going through 2 other points. You have to find which line has a higher slope. So let's first understand what is meant by slope. So I've drawn a very simple geometrical mountain. This mountain has a constant upward slope, a peak. I try to draw snow here, and then from the peak the mountain has a downward slope again on the other side. It's kind of symmetric, just to help us learn this slope concept. Slope means how steep is this angle that is taking you upward. This is that slope angle. Okay? And mathematically, slope is defined by how much do you rise as you walk up the mountain and how much lateral movement do you have. This is called run. Rise versus run. So if I go from, let's say, from here to here, the rise that I will have will be, let's draw it. This will be the rise. So let's call this points point A and point B, and then point C. So I should write going from A to B, rise will be this much, and I've drawn a set of axes x and y. You can choose it anywhere, but for this exercise I'm just going to use this x and this y axis. So here I can see this is 1 unit, this is the origin, the 0, 0. This is 1 unit, 2 unit, and 3 unit. And in this direction, this is -1, -2, and -3. So from here to here, the number of units of x and the number of units of y from here to here, that's basically your rise and run. So rise is 1, 2, 3, and 4 units. And run, this is the lateral movement, or how much you have moved, will be 1 unit, 2 units, 3 units, 4 units, 5 units, and 6 units. So run is 6 units. And slope is the ratio of rise and run. Okay. Now remember that the rise is upward and run is in the positive direction. So if you are going in the positive direction and you're rising upward, then you will take the rise as positive and the run as positive. So in this case, they are 4 divided by 6. You can cancel the factor 2, or 2 over 3. Okay. But let's say we want to go from B downward to C. In that case, you are actually climbing downward. So your rise is actually negative. You're not rising upward. You're sort of rising downward, kind of, so to speak. we don't use a different word, we still use the word rise, but make it negative. So in this case, your rise is negative and your run is positive, because you're moving from this point towards this point in the lateral motion, and in the vertical direction you're coming downward. You can take it also the same if you go from this point C towards point B. Your rise will be upward, so it is positive, but your run will be negative because it's in the negative x direction. Okay, so you can take it either way. Going from B to C, rise equals negative 4 units, and run equals positive 6 units. Why 6 units? Let's calculate. 1 unit, 2 unit, 3, 4, 5, and 6 units. So here the slope, so here the first one was slope of AB, that line. Here the slope of BC will be minus 4 divided by 6, cancelling again the factor 2, this is 2 and 3, so the answer is minus 2 by 3 in this case. So the slope is negative when you are coming downward, and the slope is positive when you are going upward. The way to think of it also is, if you have an acute angle with the x-axis, that is always in the positive direction then. So this is acute. This is an acute angle, and whereas in this case this angle is an obtuse angle. This line BC is making an obtuse angle with the positive x-axis. In that case you will have a negative slope because it is actually coming downward. So this is what I would like you to kind of understand a little bit better. Let me unzoom it. Yeah. So I would like you to understand this before we proceed. What is meant by slope? So when a line is going through 2 points, let's locate this line 7 and minus 2. Let me draw the coordinate system one more time on this side, and then I will let you do that. You can pause the video and then proceed after that. Okay, I have drawn the axis on this side. We are going to use it. So that line L1 is passing through 7 comma minus 2. So let's locate that. Again, this is your origin 0 0. So 7 comma minus 2 will be 1 2 3 4 5 6 7. It's 2 directions, so this is 7 comma minus 2. And 9 comma 3 would be, this would be 9, and then 3 will be in the upward direction, 1 2 and 3. So that is 9 comma 3. So the line L1 passes through these 2 points. So let's draw it very carefully, again avoiding any parallax, making sure the line exactly passes through them. So that is your line L1. Now let's draw L2. L2 passes through -1, 6. So this is your -1 for the x, and 6 will be in the upward direction. 1, 2, 3, 4, 5, 6. -1, 6. And the other point is -4, 3. So 1, 2, 3, 4, that will be -4, and comma 3 in the positive direction. 1, 2, and 3. So this is L2. Let's name the point -4, 3. So which angle do you think which has a higher slope? The slope, as I mentioned, this is the slope angle, and slope, the value of slope is rise divided by run. So this is easy to see that this angle is higher. If you have a higher angle, and both are acute angles, if you have a higher angle, then this line will definitely be steeper or has a higher slope. So you can say part A, line 1 has a higher slope than line 2. So that's a statement, but if someone wants you to actually find the value of the slope, then what you have to do is take these points, these 2 points, and you can calculate the rise versus run. Because these are linear lines, or these are linear equations, and these lines are straight lines, whether you take the point from here to here and see what the rise versus run is, or you take a smaller segment of the line like this, that does not really matter. Okay, so let's do that. So slope of L1 is rise. How much rise do I have going from this point to here? 1, 2, and 3 units, that will be the run, and 1, 2, and 3 units, that will be the rise. So the rise is 3 units, and the run is also 3 units in the positive direction for each of them. So slope of line L1 is 1, and slope, I'm sorry, I should have written here line 2 has a line 1 has a higher slope. No, I'm right. Yeah, this is slope of line 2 is what I calculated right now. I'm sorry about that. So please correct it. Its slope of line 2 is just being calculated. And for here, I can do the same thing. from 7 to 9, from x equal to 7 to x equal to 9, I've moved 2 units. So slope of L1 is rise versus run, or rise over run. Run is 2 units, and the rise is, let's calculate the rise from minus 2 units to plus 3 units. So that's the difference will be 5 units. So this is 5 over 2. Okay, so you can leave it 5 over 2, and you know that 5 over 2 is 2.5 is greater than 1. So looking at the angles, we can say the line L1 is steeper or has a higher slope, and also looking at the values of slope, we can also say that the line L1 or L1 is having a higher slope. So that is your answer. Okay, in 9.2 part B, we have to find where the two lines L1 and L2 intersect. So in the previous page, as we have shown, they would be meeting if we extend them further to the right. Okay, so you can see here they would be meeting if I have taken this line further up here, and if this L1 line, if I have taken further up here. So somewhere they would be meeting. Since I have not enough space, I redrew it with the full page as shown here. So let me zoom out. So this is the full page. We have drawn this x-axis and y-axis, and we have relocated these 2 points here, and then these 2 points here, and during the L1 and L2, they're meeting somewhere here, and it so happens that they are not exactly meeting on it, more in the middle of the box. So I've taken 17.5 and 24.5. If you look very, very closely, they are not exactly in the middle, maybe a little bit to the side in the x direction, but I've chosen 17.5 and 24.5 as approximately the solution. What we want to do is, now that we have the intersection point, I want to make checks. I want to check if this point is indeed on L1 as well as on L2. And the way to do it is, so L1 is passing through these 2 points which are already given. My claim is that this point 17.5 and 24.5 is also on L1. And if that happens, because this is a linear equation, or it's a straight line, if I calculate the slope with this third point and one of these other 2 points, let's say I chose 9.3, then the slope should come out to be the same as what we found in the previous part. So slope of L1 I calculated using these 2 points. First is rise. Rise will be what the y-axis values are. Okay, the difference of y-axis values, 24.5 minus 3, and then run will be the x-axis values difference, 17.5 minus 9, and then it is 21.5 divided by 8.5. If you use a calculator, you can use it, you can do by hand also, but if you use a calculator, it's easier. 2.53 is the answer, which is very close to 2.5 or 5 over 2. So this sort of checks out. Now, would you have been more accurate if your if the intersection point was 17.6? I think you would be more accurate. But I think 17.5 and 24.5, these are good enough solutions because they're giving you very, very close slopes. Same I did with L2. L2 is passing through these 2 points. I'm claiming that this third point is also on L2. And then I'm calculating the slope of L2 using that third point that I'm claiming. and then any of these given points. Again, I did rise over run, and I found that the slope is 1. And you know from the previous part, the slope is indeed 1. So that's why it checks out both here for L1 and also for L2. So the solution is 17.5 and 24.5. That's the intersection point, and that satisfies both the lines. Okay, so do check this. I know checking is a little bit tedious. Why do I have to check it? You will ask. Sometimes, when you are doing these calculations, if these points are meeting far away, you may not have done the math correctly in some step, and maybe you missed it. So it's always a good idea, no matter whether it's an equation solution or graphing or some other technique, do go back and check your solutions. That always will help you. Okay, so hopefully you like this video. I will probably do one more video in this particular topic where we will basically talk about what a slope and a constant is in a linear equation. So watch out for the next video.